Welcome back to our second day of exponential logarithmic equations. So yesterday we talked about the exponential side of things. Now today we're going to transition to how to deal with a logarithmic equation. Now, logarithmic equations, the way that we solve them, there's two steps, two key things to recognize when attempting to solve these. First thing is you want to condense them if possible. I'll point out what this means when we get there. That's why we practice that skill in the properties of logarithms. We practice condensing because that's how you handle solving the equations. Now, the more important piece is you want to rewrite it in exponential form and solve it. All right? That's really the key part here. All right? So, let's dive right in and see what this looks like. Now, one thing to remember here that when you're solving these is if you just see log, remember that really means log base 10. All right? So I'm going to write in that little 10 there to remind myself that's really what this means. Now, recall way back when this chapter started, I introduced you to that little cheesy concept that my teacher taught me as Mr. Loopy. That's what we're going to do to rewrite this in an exponential form. I'm going to take 10 to the 2. So 10 to the second equals 4x minus 3. All right, remember that whole Mr. Loopy concept? And again, I know it's super cheesy, but if I remember it 10 years later, you guys will hopefully remember it based on that. So I've rewritten this in exponential form. 10 squared equals 4x minus 3. Well, I know what 10 squared is. I know that that's 100. And I'm looking at that, well, that's just a basic linear equation at this point. Once I convert it, now I have something that's really easy to solve. All I have to do is add 3 and then divide by 4. Now you can leave it as a fraction just fine, but since this one, dividing by 4, leads to nice decimals, if you want to call this 25.75, that's fine. As long as it's a terminating decimal, I'm okay if you use decimal form. If it's one of those repeating ones, like a third, make sure you just leave it as a fraction for me. But again, it's actually not that hard. It's not that complicated. So let's try another one. So again, if you just see a log, remember that really means log base 10. And now I'm going to use Mr. Loopy. 10 to the negative 1 equals 3 minus 2x. 10 to the negative 1. Again, that's just a number. That is actually just 0.1. All right, so now again, while I have a decimal, which usually we don't enjoy, but this is just something linear, something I know how to solve. So I'm going to subtract 3 from both sides. So I get negative 2.9 equals negative 2. Remember, subtracting off that 3 does not remove the negative from the 2x. And now I'm going to divide both sides by negative 2. So my x is equal to, well, negative 2.9 divided by negative 2 gives me 1.45. All right, let's do another one. Now, this next one, this is where that whole condensing part comes in. Because we have log 6 minus log 3x. So this is where the whole condensing thing comes in. Because I'm going to want to rewrite this side as a single logarithm. Remember, subtraction becomes division. All right, so that's the key to this one is when there's multiple logarithms, you're most definitely going to want to condense them. All right? Now, inside there, 6 divided by 3x, well, that 6 divided by 3 is going to become a 2. So I'm going to clean up my equation to look like that. Now, what's up to this point? Now, everything is exactly the same as what we've already been doing. So, I want you to notice, remember, when you don't see a base, remember it's base 10. And now I'm going to use Mr. Loopy. 10 to the negative 2 equals 2 over x. Well, 10 to the negative 2, 10 to the negative, 10 to the negative 2 is 0.01. Now, remember when we were doing all that trig stuff, when I have that x in the denominator, okay, remember, you know what to do with this. I'm going to multiply the x over. I just want that x out of the denominator. We can't do anything with an x in a denominator. And now I'm going to divide by 0.01. So my x is going to be 200. So that's one of my condensing strategies. Now, the other one, the other condensing strategy looks like this. When I'm adding, remember adding turns into multiplying. So this turns in to that. So I'm going to have log of x squared minus 3x. And all I've done is distributed that in. And now that I have that, now that I've condensed by turning addition into multiplication, now I'm ready to use Mr. Loopy to write this in exponential form. 10 to the first equals x squared minus 3x. Now again, anything to the first power, that first part doesn't really matter, so I'm just going to call that 10. All right, well, now we have the complication of we're not getting something linear this time, we're getting something quadratic. When you get something quadratic, what I need you to remember, the way to take care of that is first and foremost, you need to get everything on one side of the equation. So once you subtract that 10 off, now hopefully you remember when you see quadratics, hopefully you remember that your strategy is factoring. So multiplying to negative 10, adding to negative 3, I'm going to get x minus 5 and x plus 2. That's going to give me a solution of x equals 5. That's going to give me a solution of x equals negative 2. Whenever you get multiple solutions, remember when we did this with radical equations with square roots, I would always have to check to make sure it actually worked, check that it was a true solution. Same thing here. Now, what I want you to notice, that x equals negative 2. Notice, if I put that in here or here, notice I would be taking the logarithm of a negative number. And we explored that concept on the first day that we started this chapter. We explored the concept that you can't take a log of a negative number. So what that means is that x equals negative 2 is not actually a solution. So my expectation is the same thing as those radical equations. When you get a negative as a solution, something that doesn't work, and remember that's called an extraneous solution, when you get that, I want to see that you got it, but I want you to cross it off to recognize it is not actually a solution. If you don't cross it off, that will cost you probably half a point, but I do want to see that your math got you to that number, just that you recognize it is not an actual solution. All right, so those are all of the basics. Now I wanted to show you just a couple word problems, and then we'll be done with these notes. So the wind speed s in miles per hour near the center of a tornado is related to the distance d in miles the tornado travels by the equation s equals 93 log d plus 65. On March 18th, 1925, a tornado whose wind speed was about 280 miles per hour struck the Midwest. How far did this tornado travel? All right, so the first thing I'm noticing is they're giving me a value. They're giving me 280 miles per hour. That is a speed. All right, so I'm going to write that in as a speed. So I'm going to say 280 equals 93 log d plus 65. Now remember, the key here is we always need either the exponential or the logarithm by itself. All right, so we have some work to do here. I need to get these things away from my logarithm. So I'm going to subtract off 65 from both sides. So I'm going to get 215 93 log d, because it cancels that off. I'm going to divide by 93. Now, I'm actually going to leave it written in exact form like that, because if I try to write that as a decimal, that is going to become a nasty decimal. So for now, I'm just going to leave it exact. All right, leave it as that fraction. Well, now we get to use Mr. Loopy. Now that my logarithm is by itself, it's time to use Mr. Loopy on this. So 10 to that nasty power. So 10 to the 215 over 93 equals d, equals that distance. All right, so when you're typing it in, please make sure you're using parentheses around that. So 10 to the 215 divided by 93. That distance that it traveled, you should get about 205 miles. That's how far that tornado went. So you can see in word problems, basically, when they give you the equation, you just find which piece to plug it in for, and then start rearranging and solving for the rest. So the Richter scale is used for measuring the magnitude of an earthquake. The Richter scale magnitude is given by R equals 0.67 log to the 0.37 E plus 1.46, where E is energy in kilowatt hours released by the earthquake. So talking about the energy released by the earthquake compared to its reading on the Richter scale. Those are the two things that we are comparing. How many kilowatt hours of energy would an earthquake have to release in order to be an 8.5 on the Richter scale? So again, the first thing I do is I look and see, okay, 8.5 is the actual reading on the Richter scale. So I'm going to plug that in for R. So if I know that I have an earthquake that read that on the Richter scale, now I want to figure out what was its energy released. Well, this is the same as the last one. I need to get the logarithm by itself. So the first thing I'm going to do, I'm going to subtract off the 1.46 from both sides. So 8.5 minus 1.46, I get 7.04. I'm going to divide by 0.67. All right, now here, again, I want to stay as precise as possible. So when you divide this to 7.04 divided by 0.67, you're going to get about 10.51. But again, to stay as precise as possible, as long as possible, I'm going to tell my calculator, hey, you know what? I want you to take that number for me, turn it into a fraction. Because again, to be precise, we want to stay as exact as possible. That means keeping things in a fractional form as long as possible. So while you could use that 10.51, again, to be precise, let's work with the fractional form. And with fractions, sometimes it's easier if you think of always having it in a parenthesis to make sure you don't mess up a calculation. Now it looks like it's time for Mr. Loopy. My logarithm is finally by itself, so 10, I'm going to need a little bit more space, 10 to that power equals 0.37 E. All right, now we can start doing these calculations. So 10 to the 704 divided by 67, and again, make sure you keep that in parentheses. We are getting, what our calculator tells us is 3.22 E10. Now, I will deal with that in just a moment. I will explain to you what that means. But right now, that's kind of what my calculator is telling me. Now, do keep in mind the way I'm writing it, this E is not the same as that E, all right? All I'm writing is what the calculator is giving me. Those are not the same things, okay? Take that divided by 0.37, and you are getting 8.69 e to the 10. What that means, that is your calculator's way of scientific notation. So basically what it's saying is if you take that decimal point, you move it over 10 times. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. That is your answer. That is how much energy is being released. It is an enormous amount to end up as an 8.5 on the Richter scale. A huge amount of energy. So again, I know the last one has probably got a little bit confusing. However, I want you to write it down. If you have any questions, please make sure to come in and ask me what those are. But most importantly, just come back prepared and ready for your practice work in class.